So like I was saying, it's basically just review. You've got a big definition over here for like what's a relation, what's a function. That's something that you've talked about since Math 1 at least. We probably even did it in 8th grade. So I'm not going to read that to you. Just looking at the equation, can we tell if it's a function or not? What type of equation is this? Linear, right? And we know that a line, like visualize that in your head. What's the graph going to look like? A line. Is that going to pass the vertical line test? Yeah, so it's a function. I think that's the easiest way to do it. Is that okay? Make sense? Questions? Okay, cool. So it says determine if it's a function. Yes, it is, because it's a line. If you want to like sketch the line of that, you can. We could say passes a vertical line test. Whatever you want to add on there so that it makes sense for you. So the next one is x equals y squared minus 1. Is that one going to be a function? So we're thinking no. Why not? If you've got a y squared, what is the graph going to look like? Like a parabola on its side. Yeah. So like your normal parabola, flip it on its side. So it's going to look like this. Is that going to pass the vertical line test? No. Yeah, so you'd have like the positive square root, which is going to give you the top, and the negative square root, which would give you the bottom. So fun fact, if you have like a really old calculator and you need to graph one of those, that's how you do it. You have to type the negative square root and the positive square root. That's how you get that to pop up. Y'all's calculators do it because they're smart. When I was in school, my calculator was not that smart, so we had to do it the other way. Are we good with all that? Questions? Okay, cool. So the next section is just evaluating a function, which we did that on the bell ringer a little bit and on the pre-assessment that you just did. So I don't want to do all of these. We've got 3 through 10. Y'all pick a couple. I definitely want to do 10. Pick a couple more that you want to do. Did I hear a 4? Y'all gotta talk to me. You're all just like staring at me right now. Like, it is okay to talk. Tell me what you want to do. This is for you. Number 3. Number 10, we're definitely doing. Pick a couple more. Or one more. 8. Cool. Is that enough? Sounds good. Cool. All right. So for f of 3, how are we going to figure that out? Just plug in a 3. So you're going to have 2 times 3 squared minus 3 times 3. So we're going to try to do as much as we can without a calculator in this class, so we'll go ahead and start that now. What is 3 squared? 9 times 2 gives you 18, and then we have 18 minus, what, 3 times 3? 9, so 18 minus 9 gives us 9. Final answer. Good? Questions? Okay, cool. We're doing number 8 as well. So this time, what are we plugging in place of x? 3x. So we're going to have 2, but instead of a 3, we're going to put 3x squared minus 3 times 3x. So we have all of 3x squared. So what is that going to be? 9x squared, right? Because the 3 is squared and the 9 is squared. Yeah? So that's going to be 2 times 9x squared minus 3 times 3x, so 9x. And then our last step will just be the 2 times 9x squared. So we'll have 18x squared minus 9x. Is that all right? Yeah. Yeah, we can do 7. Are we good with 8? Yeah? All right, so for 7, it has a negative sign outside f of x. So what do we think we would need to do? Whole thing negative. So instead of a positive 2x squared, what are we going to have? Negative 2x squared. And instead of a negative 3x, what are we going to have? Positive 3x. Can we actually do 6 as well? Yeah, cool. Let's do that one real quick. So this one wants it with a negative x being plugged in. So I'm going to break that down probably a little bit more than some of you need, but I want you to know exactly where this stuff is coming from. So we're going to put in a negative x, square it, and then we'll have negative 3 times negative x. Is that okay? Everybody good so far? So if I have a negative x and I square it, what happens? It's not negative anymore, so that's just 2x squared Then we have negative 3 times negative x. What happens there? Plus 3x. Do we have any questions about the difference between these two? So we're all good? Because that's going to come back like tomorrow. Good to go? Okay, cool. We're going to skip number 9 because I think we're good there. And moving on to number 10. So number 10 is my favorite kind of thing because this is what we start to do in calculus. So it's really important that you do know how to do these. So we're going to plug in x plus h first. And then we're going to plug in x, and then we're going to put it all over h. So we're plugging in x plus h up here. So what are we going to have to do when it's squared? Do the box or FOIL, whichever you prefer. Minus 3 times x plus h. So all of that is just plugging in for x plus h. Yeah? So then we're going to subtract, and we're going to just do our whole function because it's just f of x. So I'm going to use parentheses around all that. 2x squared minus 3x. And everything is over h. Any questions so far? All right. So when you do the box or FOIL, what do you get right here? X plus h squared. X squared plus 2xh plus h squared. That okay? I'm going to go ahead and distribute the negative 3 as well. So we'll have negative 3x and negative 3h. And I'm distributing the negative to all this stuff over here as well. I wrote way too big. Minus 2x squared plus 3x. And things over h. Everybody still with me? So next we have to distribute a 2, and then we'll start canceling stuff out. So in that numerator, what will cancel? We got a 2x squared and a negative 2x squared. They go away. What else? Negative 3x, positive 3x, they cancel. Okay, so then we have 4xh plus 2h squared minus 3h all over h. So what else could we do? Divide all the h's off. Does that make any sense? Like you could like factor out h from the top, or we can just mark out this h, mark out one of those h's, mark out this h, and get rid of that guy. So you're left with 4x 2h minus 3, or plus 2h right there. That would be your final answer. Yeah.
So why did the 3x's cancel out? Because did I write it down wrong?
Maybe.
Minus 3x.
Yeah, you should have had a negative 3x then.
Wait, which one was positive?
The last one here. We had to subtract the whole thing. So if you don't use parentheses up here, then that'll mess that up. Any other questions? Alright. So that's all of that. Are we okay? Do you have any questions for any of that sort of thing? Okay. Alright, so next we're going to talk about domain. So we know that there are constraints on our domain. We already talked about a few of them, kinda, with the log stuff that we were doing earlier. The most important ones that you have to know for pre-calculus are if you've got a square root, you can't have negatives under there, right? So whatever is happening in your square root, it's got to be greater than 0. And then if you have a fraction, so stuff in the denominator also can equal 0. So we're going to do that with these guys here. So for the first one, it's a fraction, so we know that our denominator cannot equal 0. So to like list your domain, you have to find the stuff that 0 cannot be, so that you can say, hey, x can't be this and this, and your domain is everything else. Does that make any sense? Okay, so we're going to do that. So to figure out what would make that denominator 0, what do you think we might need to do? Yeah, so we'll factor, and we're going to set it equal to 0 and then solve. nothing cancels on this one, unfortunately. So we'll have x squared minus 2x. I'm going to go ahead and set it equal to 0 first, and then we'll factor. So what will that factor into? Do we know yet? X minus 3x plus 1. So then we know that x equals 3, x equals negative 1. So for our purposes, we would say that the domain cannot be negative 1 and cannot be 3. So I'm totally okay if you just say x can't be 3, x can't be negative 1. However, your test is going to be a little bit more picky than that, and they may write it in interval notation. So we briefly talked about that yesterday, but we didn't do a whole lot with it. So if we're saying that our domain is going to be everything except for negative 1 and 3, we'll say we're going to go from negative infinity to negative 1. And do you remember how we join union? So then we'll go negative 1 to 3, and then 3 to positive infinity. And that would be like how you write your domain formally. So you could say domain equals all that stuff. Questions? Alrighty. So if we look at the next one, what kind of function is that? It's a quadratic, so it's like a polynomial. Is there anything funky happening as far as fractions or square roots, radicals? Nothing's going on there. So fun fact, as long as it's a polynomial, your domain is always all reals. Yeah? So this is just a regular old polynomial. We should be able to tell what that graph looks like in our head, right? It's going to be a parabola shifted down 9. So your domain is all reals. And that's that. Is that okay? Cool. How would we write that in interval notation? I heard somebody say it. Negative infinity to positive infinity. So again, anytime you just have a regular old polynomial, your domain will always be all reals. For 13, we have that square root happening. So we've got to make sure that whatever is underneath it is greater than 0. So kind of similar to what we did over here. We set the denominator equal to 0 and said our values can't be that. We're going to set the stuff under the radical greater than 0 and then solve that way. So we'll say 3 minus 2x is greater than 0 and then solve that inequality. So we'll minus 3 divide by negative 2. And when you divide by a negative, what happens with your inequality? Flips it. I always forget this, but it should technically be equal to, because can you have a 0 under a square root? You can. It's not like a math is not going to exist anymore. So you can make that equal to. When we go write this in interval notation, how are we going to do it? Negative infinity to 3 over 2. And we'll have a bracket on that 3 over 2 just because we have an equal to. If you didn't have an equal to there, then you would just do parentheses. I'm not going to be a stickler for which one you put there, so as long as you get the right interval, I'm good. Questions? Did we do this in Math 3?
Yes.
Yeah? Okay, good. I'm dying a little bit, but it's okay. So the next section, I'm going to be very, very honest with you. Like, I don't even want to do it. So it's just talking about, like, if you have more than one function, how that affects your domain. And there's, like, rules that you can memorize and, like, what happens. But I think it's easiest to just go ahead and, like, add the functions or subtract them or multiply them or divide them or whatever. And then, like, reevaluate your domain from there. So I don't want to do any of this. Is it okay if we just don't? Yeah? Okay. Are you sure? Okay. I don't want you to feel like cheated out of your pre-calculus experience. You did it in Math 3, right? Okay, so I'm just saving you time. If you have questions about it later and you like really want to know, then you can tell me and we'll figure it out. All right, the next section is vertical line test. This is easy peasy, right? So just tell me if it's a, what does it say? Identify the graphs that represent a function and the domains for all of them. Cool. So we're going to do that. Are we going to do that? Can we just talk about it? I don't want to write. For 18, what kind of graph is that? A parabola or a parabola. My math 1 kids always like to say parabola. So your domain there is what? All reals. Yeah, good. Wonderful. 19, what kind of graph is that? Do we know? It is cube. Yeah. It's a cubic function. So your is it a function? Yeah, and what's your domain going to be? All reals. Yay. What about number 20? Is that one a function? No. What would your domain be though? From 0 to infinity. As this moves left or right, that would change, right? So y'all did inverses in Math 3, yeah? So I think somebody was saying this is kind of like the inverse of like your regular parabola, right? So we'll talk later, and y'all may have already discussed it in Math 3, how the domain and range flip with the inverse. So like the domain of a parabola is all reals, so the range of this one is all reals. They kind of like go together like that, but we'll do a whole lot more of that later. And what about 21? Is that a function? No, what is it? And we know our standard form for that, right? Because it was on your pre-assessment. Yeah. Okay, cool. We'll move on. Yay, that was good. So the next section is like that whole, the graph is increasing here, it's decreasing here, blah, 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 all that stuff. We've done that. Yeah. I'm pretty sure if you had me for Math 2, we did this in Math 2. So y'all should be experts basically. So what are f of 0, f of 3 pi over 2, and f of 3 pi? So just pull that information from the graph, yeah? So f of 0, that means when x equals 0, what does the function equal? Like what is y? So what is that? 4. Wonderful. You guys are so smart. So what about, it would be helpful if y'all could see this. I'm so sorry. For f of 3 pi over 2. 3 pi over 2, I cannot even read this graph right there. 0, yeah? And then what about 3 pi? Where even is 3 pi? Negative 4. Are we okay with that? Pulling that information on the graph? Do we have any questions? Okay. So what's the domain of that function? Are there arrows on the end? No, so it's not going to keep going. So it's only from 0 to what? Four pi. So we'll say we're going to use brackets because it's got like those closed circles. What do I say? 0 to 4 pi. What about the range? Negative 4, positive 4. What are intercepts there? Ooh, all of them. X-intercepts, Y-intercepts. We'll do both. We'll do Y-intercept first because there's only one. What is it? 4. So can we write that as an ordered pair? And say 0, 4. What about X-intercepts? Pi over 2. What else? 3 pi over 2. I know those numbers are not super easy to read. I'm sorry. Next one is what? 5 pi over 2. And last one? Yeah. So the next part wants to know how many times does the line y equals 2 intersect the graph. So before we like even talk about that, if you have the line y equals 2, what's it going to look like? Y is horizontal, yeah? So y is going to go across this way at 2. So like we could take your pencil and like put a flat line at 2, or you could like sketch that in. How many times does it cross? 4. Is that okay? the next part, for what values of x does f of x equal -4? That's the same question again with a different number. So instead of it being 2, we're now at -4. So how many times does it equal -4? 2 times. And then at the bottom it says, for what values of x is f of x greater than 0? I'm falling. That's essentially just asking you where is the graph above the x-axis. So that's 3 little chunks. Yeah? We'll need to write those chunks in interval notation. So it's going to be from 0 to pi over 2. Yeah? And then where's our next chunk? 3 pi over 2 to 5 pi over 2. And our last chunk. It's like y'all want to say it, but you're afraid. You're like 7 pi over 2 to 4 pi over 2. Or just 4 pi. Sorry. I was really rolling with those over 2s. We can put a bracket at the end because it does equal. Does it equal 0 there? It doesn't. What is it asking? Whatever. Just got to close circle. You can put a bracket or parentheses at the end. Again, I'm not going to be a stickler for that. I don't really care which way you do it as long as you got the right numbers in here. So, questions on any of that? Alrighty. Do we want to do the rest of this? Yeah, we probably should. Okay, so the next function that we have is x plus 1 over x plus 2. We need to find the domain. So it would be super easy to like look at a graph and find that. However, we're not going to. We're going to do it by hand. So we know that you cannot have 0 in the denominator, right? So what value would make your denominator 0? -2. Easy. So we'll just say x cannot be -2, and I'm good if you leave your domain just like that. If you wanted to write it in interval notation, how would you do that? -infinity to -2, union -2 to positive infinity. I wrote way too big again. Is that okay? Alright, so the next part, we want to know if the point 1/2 is on the graph. We're not going to look on a calculator or look on a graph. How can we figure that out? Plug it in. I think that 1's going to be super easy to plug in, so if I plug in 1, do I get 1/2 out? That's what we want to know. So what is 1 plus 1? 2, and what is 1 plus 2? So is 1 over 3 the same thing as 1 over 2? No. So is this point on the graph? No. Not okay? So I don't really have any work to show for that. We'll just say no. I guess we could write that fraction. We had 2 over 3. I probably said that backwards earlier. So the next part, it says if x equals 2, what is f of x? What point is on the graph of I think that's typed wrong. We're just basically going to find f of 2. Is that okay? Yeah. Do we need to like do that together? I mean, it'll take 2 seconds. So f of 2, plug in a 2. What's 1 plus 2? 3, and then 2 plus 2. So you have 3 over 4. Is that okay? If x equals 2, what is f of x? Oh. That's just worded weird. Don't put it on the graph. So if you were going to as a point, that would be 2 3/4. For the last one, is it okay if we just talk about it? Yeah? Okay, so you've got a function. It's the average cost of manufacturing X number of computers per day. So to determine the cost of manufacturing 30 computers in a day, what would you do? Plug in 30. So to find 40 and 50, what would you do? Plug it in. So I think it would be easy, especially if you have something messy like this, to put it, like graph it, and then pull up the table. Does that make sense? And just scroll to 30, scroll to 40, 50. Or you can plug it in on the calculator screen. I don't care how you do it as long as you get the answer. Then it wants you to graph it, and it wants to know which value of x would minimize your average cost. So if it's saying that word minimize, what do you probably need to find on the graph? The minimum. Do we remember how to do that? It's like menu, analyze graph, minimum. Yeah. Questions on any of that? Okay, cool. So we're done for today. Yay. At least with that stuff.